Okay, so this question is again from the A-level chemistry, and my some of the students really found it tricky when they were doing the mocks with us, and I thought to just quickly make a video clip on this. Question says 2-chlorobutane, and they gave you the formula, is an organic liquid, and its boiling point is 70 degrees Celsius. The student prepares 2-chlorobutane from butane 2-ol, as shown in the equation, and the student method he used 9.25 gram of the alcohol and with the excess of NaCl in the pear-shaped flask he put, and then he added excess of sulfuric acid as well, and then he under reflux heated it for 45 minutes. The student obtained reaction mixture containing organic layer. The density of organic layer has been given, and the aqueous layer and the density of aqueous layer has been given. We will talk why we will get layers in a minute. After purification, percentage yield of the desired product you had was 65%. They clearly ask you, now this is the key where people lose mark. Describe how the student can obtain pure. You have to tell something how you can get the purity. Dry, how will you dry them of this product from the reaction mixture, and then you explain why you did that step, right? Then only you will get full marks on this. And then you calculate the mass of pure product that would be expected from the preparation. So there are three parts of this question, okay? Explanation, steps and explanation, and then calculation to get 6 marks. So now what why this, so when the student has put this reaction in the, we call it separating funnel, the diagram that you see, this is how it looks like. And what the student is doing, he's just literally putting in the entire mixture. Remember, you did reacted the alcohol with these two reactants. You cannot have only your desired product, you will have impurities right all over the place in the mixture, and you want your desired, this is your desired product from the whole separation technique, okay? So what happens is that the top layer, now automatically you will see that when you put this in the separating funnel, there will be two layer. One is the top layer, which is called organic layer. So this is your organic layer, okay? Why is this called organic layer? And this is your aqueous, the bottom one is called your aqueous layer. First you understand why these layers have been formed. Aqueous layer, okay? The mixture separates into two layers because some substances are soluble in water. Now where does the water come from? So if you see this one here, we have water. Your acid are always aqueous, salt are aqueous. So they did not give you the state symbol, but you know from your knowledge that acids are substances which release H plus ion when dissolved in water. So they are aqueous, right? So you have water all over the place. Now some of the particles, now you know that water is a polar molecule. It has a delta negative and a delta positive charge, right? And out of all of these, now you would have little of every reactant and product present, right? Now in this water molecule, anything which is polar will dissolve. And for example, out if you just look at the reactants, you have NaCl, H2SO4, NaHSO4. All of these are polar molecules. And if I just tell you how, I can polar, or you can say ionic molecules or ionic substances, right? This is purely ionic. It breaks down into Na plus and Cl minus. Remember, H2SO4 is purely ionic. This is ionic, and water is polar. So what happens is that they dissolve in water quite well because of the charge they have. So in the aqueous layer, I would be having my water in which I will dissolve my H2SO4, whatever remaining H2SO4 you have, and your NaCl, all everything will be dissolved here, right? And on the top layer, now they have given you the density as well, which is another key thing that people miss. The density of your aqueous layer is quite high compared to the density of the organic layer. So the density given is 1 gram per centimeter cube. And organic layer, now let's talk about organic layer. What do you have in the organic layer is this. If I show you this compound, this your desired organic compound, this is what you were aiming for. So I made the particle model, like particles as well, to show you. This is, I'm just going to show you with an arrow. This is going to be my in my organic layer, okay? Now why is it not polar? It is having very little polarity. If you see, there is Cl present, but the polarity difference between the electronegativity difference between carbon and Cl is less. Therefore it is comparatively or relatively non-polar molecule compared to every other substance, okay? That is why it is going to come in the top organic layer. But you will have a little bit of, just to let you know, this part is again people don't understand this one. You also still have some of the in this organic layer where you have your halogenol alkane present, which is relatively non-polar, so will not dissolve in water. You do have a little bit of alcohol present in it. Remember, alcohol normally goes into the aqueous layer because of the hydrogen bonding it will create with water molecules. And you know why alcohol could be produce cause hydrogen bonding. Think about it. Why? Because they have OH bond. OH bond is a oxygen directly connected to hydrogen. So therefore hydrogen bonding. But not, see, now this is again another trick. Remember, the alcohol will be, yes, it will be polar, but and it will be dissolved in water, but because of the carbon chain present, it will also be somehow a little bit solubility it will show inside the organic layer as well. So it is not purely soluble in water. It does soluble or that dissolves a little bit in the organic layer, and that is why we need to separate it out. Now what we simply do is that we um, because the density of the bottom layer is 1 gram, so it is heavier, and your top layer where you have your desired substance is 0.87 gram per centimeter cube. This is lighter. So you will remove this part by turning this tap on and get it in the beaker and remove it. So what we will do, we will remove this part, this part. This will be removed. Okay. So then you will be left with your organic layer, okay, which is on the top. And now you need to tell, now it comes, now you know the understanding of what is happening and how things are happening. You remove your layer, the heavier layer, which was water soluble. Now is your explanation comes, and you write for a 6 marker. Simply just say that the main steps of purification are: number one, use a separating funnel. Use a separating funnel. And why we are using that for separating funnel? To separate organic layer from aqueous layer. Why we are using it? Because they said explain each step. To separate organic and aqueous layer. Okay, that's your first point to tell about how will you do the separation. Second one is to add anhydrous anhydrous salt. Why? Now, you know how I showed you that the top layer contains your desired substance? You would have little bit of water present into the top layer, because when you just separate it, you can't just be precise enough to separate the exact amount or low or get rid of the exact amount. A little bit of water will definitely be left on the top. So you need to remove that. And they said clearly in the question, how would you get the dry sample? So you need to remove the water molecules from your desired sample. So you add anhydrous salt. This anhydrous salt will, why you are doing that? Because this will dry the organic layer. Anhydrous salt will add anhydrous salt, which will dry, which will dry the organic layer. Okay, organic layer. So this is your explanation. Third point is then distillation. Can you see I have drawn distillation? Can you see this is the distillation apparatus I have shown you here? Now, why distillation is important? Because I told you just now that in your desired top layer, you will have a little bit of alcohol present as well. Remember, alcohol is, yeah, it is polar. It is going to be dissolved in water, but some will remain in the organic layer because of the carbon chain. It is not fully soluble. It somehow dissolves in organic substances as well because of that long chain of carbon atoms. Okay, so distillation will then do what? They gave you this. They gave you, if you see on the question, I'm going to show you on the top again. They gave you this here, the boiling point of your organic, the desired 2-chlorobutane, which is 70 degrees Celsius. So if you just take your dry sample and you put it in a distillation flask, and you can just distill to remove. So distillation. Now, why we are doing distillation is to um, collect fraction, to collect fraction at 70 fraction at 70 degree Celsius, to separate product from, to separate your desired product, separate your desired product from unreacted reactant, from alcohol, you can say, from unreacted alcohol. So this gives you your pure desired substance. Now is the calculation part. So how would you do calculate the mass of your halogen alkane? So I'm just going to rub this off and tell you how to do the calculation of the desired alkane. So what is happening here? You work out first, calculate the moles of your alcohol because they gave you the mass. So simply go back to the question on the top and see what's the mass of alcohol given. Okay, they have given you the mass of alcohol and you can use your balanced equation. So if I rub off and show you clearly how your balanced equation looks like this. Okay, so you can see how your balanced equation is ratio is 1 to 1. So if you work out the moles of this, which is n equals m over mr, simply you put your um, 9.25 over mr is 74, and that will give you 0.125 moles of your alcohol. Now look at the ratio you have got. The ratio is given as 1 to 1 of your alcohol and your product. So I will simply do same mole ratio applies 1 to 1. So therefore mole of 2 dash chlorobutane is also equals to 0.125. Okay, because of the ratio. Now find the mr of chlorobutane, which is equals to 92. So if I just say mr of chlorobutane will be equals to 92, then you can calculate the theoretical mass. So the mass that you will obtain will be equals to number of moles times the mr, which is equals to 0.125 times it by 92.5, and that gives you 11.56 gram. And once you get this, you apply your 65% yield, and this will give you actual mass equals the 11.656 times it by 0.65, the percentage yield, and that will be equals to 7.51 gram. And to two significant figures, you can just say 7.5 grams. Okay, I hope this makes sense. Please do let me know if you have any question. Okay, thank you.